Okay, good evening, everybody. It is 6:30, so we'll go ahead and get started here. Maybe another minute or two. I see some people still joining. Thank you all so much for being here and registering to take this class. If you're a existing spotter and just doing a refresher course, or if you're a brand new person to the spotter program, we're excited to have you. Okay, well, we will get started. My name is Charlotte Dewey. I'm a lead forecaster here in the Spokane Weather Service office, and we're going to go over our basic weather spotting course tonight. We're going to go through a lot of information, teach you a lot about thunderstorms, severe weather, how to be a spotter, what to do, and how you can help us. So hopefully we'll answer a lot of questions before you do have questions, but if you do have a question, there is a question box, and I'll get to that as soon as I can. It's off to the side right now. I'm going to try and focus on the presentation, but feel free to put a question in that question box if you need to. So this is a virtual class. It's live. I'm presenting it right now. All the sound should come through your computer. You shouldn't need to use a phone to dial in. Headphones are helpful if you have other background noises going on in whatever space you're in. And you will all be muted during the presentation, but at the end there'll be an option. I can unmute you if you do have a question and want to ask a question. So going over our course tonight, there's a couple objectives we're going to try and fulfill. We're going to help you understand the roles and importance of the Weather Spotter program, teach you how to provide accurate and timely reports of severe weather that are helpful to us, that are very, oh wait, hang on one second. Let me see. Oh yeah, okay, there we go. My slides were not advancing, so let me back up just a minute. Okay, thank you, Robin. Okay, so I didn't go very far. So here's what I was mentioning about it being a live virtual class. In the GoToWebinar environment, you are muted until the very end, and then I will unmute you if you would like to speak up. All the sound should come through your computer, so you shouldn't need your phone to dial in, and like I mentioned, headphones might be helpful. Okay, so the objectives for tonight, we're going to help you understand the roles and importance of the Weather Spotter program, teach you how to provide accurate and timely reports of severe weather, describe your community's severe weather threats so you can properly describe those threats, help you define what a severe thunderstorm is and the basic thunderstorm structure, so kind of like a Weather 101, and learn how to prepare and be safe during severe weather, because that is very important. As much as we do like those reports, we want you to be safe while doing so. So tonight is a basic weather spotting class. We do have an advanced option that you can take after you take this one at a later time, but this really gives you a good basis for everything severe weather. So before we get started with the spotter program, we're going to take a look at some severe weather that happened last year. So if you're familiar with the Spokane area, Eastern Washington, North Idaho, you may, and you were here last summer, you may see some of these events and it may ring a bell and you do remember some of those things. We had some wind and tornado damage in early May last year out on the West Plains near Airway Heights and then through south of downtown Spokane. So we had pretty good damage from those severe thunderstorms that moved through last spring. We had also some flooding. So early June, we had a lot of rainfall that was moving through. That accumulated a lot and had moved through areas that had really poor drainage. So we saw a lot of flooding in early part of June out on the Palouse River, the St. Joe River, and the Pend Oreille River. And so that is severe weather as well. The flooding is a severe weather threat as well, so not just thunderstorms. And then moving into July, so now we're more into our convective season. We have thunderstorms, still have heavy rain producing thunderstorms that move through. And if you're familiar with this area of the country, we do have a lot of wildfires. And so years of wildfires, will create a burn scar area, and if it's in the steep terrain of our mountain and hilly areas, those areas are more susceptible to flooding after it's been burned. And so once we get heavy rain through those areas, we'll get debris flow where the debris and stuff on the hillside doesn't soak up the rain as well, and so it causes it all to slide down that hill. And if you happen to live down towards the bottom of that hill and in the area, you may be impacted by those burn scar or debris flows from flash flooding. And then in August, we had a lot more severe weather move through. The image on the left stone is a hailstone and the right is an egg. So that was just used for reference of size. And that's a very large hailstone for this part of the country. We don't typically see your huge hail stones and the really strong and lines of thunderstorms like Oklahoma and Kansas and the middle part of the country does. But when we do see it, it can be pretty damaging. And so the image on the right was some broken windshields from severe thunderstorms last summer. Okay, so like I said earlier, if you are a current weather spotter and you're taking this class just because you love thunderstorms and you love severe weather and you want a refresher, thank you so much. We do appreciate all of our storm spotters, and we really rely upon our weather spotter program to give us ground truth information about severe weather and thunderstorms. If you're not a current spotter, we're also very excited to have you because we really need you, and we're glad you have a passion to be a weather spotter, because this program truly, you are the eyes and the ears of what we're doing in our office. So you being out around the area and in the region, spotting what you see and relaying that to us, it's very helpful. So if you're new to the program and you love weather, you're interested in weather, pay attention to it, you read everything you can, what you can do to become a storm spotter is you're a volunteer and you're taking the time to report severe weather and hazards to us. And so it's an as-needed basis. You're not on call every day of the year, but when we do have severe weather, if you pay attention, you see something, we'd love to hear about it. There's many ways you can reach us. You can call us, email us, or there's an online reporting option. There's no requirement to have any special weather equipment, and you become part of the eyes and ears of the National Weather Service. So you're a really useful tool, a useful resource that we can have. So here's a picture, a glimpse into our office, what it looks like on a typical day. In that picture, you can see 5 people in the office, and there's more people in the background. That's what our office looks like. It's part of our office. We have many screens. We're looking at a lot of different things, the radar, satellite, ongoing weather. We're monitoring weather stations. And so what we do as the National Weather Service, we're part of the federal government. We're under the Department of Commerce and under the umbrella of NOAA, which is the National Oceanic and Atmospheric Administration. So we're responsible for all of the weather and water watches and warnings. We work with our local agencies, our emergency managers, our school districts, our county officials, city officials. We observe and we write the forecast. And so what we do, a lot of times when people ask me what my job is, I will describe it as the behind the scenes work. You know, we're not on TV every night, every morning. We're doing more of that behind the scenes work. We're helping our partners with decision support services, helping give them the resources they need to make those decisions, and providing preparedness and education, just like this course is an educational course. So this is a glimpse of our office on the outside, and we are staffed every single day of the year, every hour of the day. We take turns working shifts. So there's always somebody here monitoring the weather, because weather doesn't stop just because it's nighttime and people typically go to sleep. We have over 20 employees. We have a mix of meteorologists, hydrologists, electronic technicians, management staff. So we kind of fulfill all of those roles. And the duties that we do, the different duties we do, like I mentioned, we take observations. We have a daily weather balloon. We measure the snow when it snows, measure the rain if it's rained, take the temperatures, maximum and minimum temperatures. We use those to create the forecast. So we forecast for aviation weather. We work with the airports. We forecast for public weather, your daily temperatures, if it's going to rain or snow, what the wind is going to be. And we also do fire weather forecasts. We issue weather watches and warnings, your severe thunderstorm warnings, your winter storm watch, your fire weather warning. Excuse me. And we do public service. So we kind of have a foot in all of those different things. So us being here in the National Weather Service in Spokane, we're one of over 120 offices across the United States, which also includes Guam, Puerto Rico, and Alaska. Our forecast area, highlighted in this red circle over here, we forecast for parts of 2 different states. So we forecast for Eastern Washington and parts of North Idaho. And so we consider ourselves more of the inland Northwest as part of the Pacific Northwest. So we forecast for 13 counties in Washington and 8 counties in North Idaho. So from the Montana border all the way to the Cascade Crest, and from the Canadian border down to almost the Oregon border. And the elevations range widely. So we have up to 9,500 feet in the North Cascades and down to around 170 feet along the mid-Columbia River. So we kind of have a mix of a lot of different types of weather based on the terrain in our region. So I mentioned taking observations. We do a weather balloon that we launch twice a day, every day, and that's the middle picture there. On the left is our radar, and so our radar outside here in the backyard is spinning every single day, every hour of the day, unless it needs maintenance, and it's always scanning the skies and helping us. And then on the right-hand side, it's an image of the satellite. So we utilize our satellite tools to get a bird's eye view. All of these tools, very helpful and very useful in what we do. So the radar, called a Doppler weather radar, and that's because it sends out a signal. It bounces off an object out in the atmosphere and sends that signal back, and then we get this picture in the bottom left-hand corner here, the reds and yellows and greens. It paints that picture for us based on what particle or what item it saw in the atmosphere, whether it was snow or hail or rain, dust. We also use radar to watch dust. And so depending on the particle size and what it is that it's viewing, that's what comes back. It depends, it'll change the shape in the picture of what it comes back and what it looks like on the radar. We can also see velocity or speed on the radar. So not just rain showers and thunderstorms or hail or tornadoes. We can see the speed. And so when we get the red and green colorings that come together, that's telling us it's a spinning motion. And so the red, when we see the red, it's a speed of something moving away from the radar, and green is moving towards the radar. And so if you can envision those two colorings next to each other, when it's trying to go away and then towards the radar very fast, there becomes a spinning motion. And so that's where we can see rotation and tornadoes. And our weather balloons, so this is a picture of, in the left-hand corner here, this is a picture of the instrument that is attached to our weather balloons, and it's not very big. It's about the size, like half the size of a water bottle, and it's very light. It's styrofoam, has a couple of aluminum instruments on it, and it's harmless. So this, on our weather balloons, that takes about 1 hour and 45 minutes, almost 2 hours to complete its flight. Once it's done, the battery on that is dead, and so it's not useful anymore, and it can be recycled. But what it does is when we launch it, it's taking a measurement of the atmosphere right then and right there, all the way up, from the surface all the way up. And on the right-hand side here, you can see there's a chart that shows height going up in the atmosphere. So an airplane flying at a cruising level of about 34,000 feet, also 10,000 meters or about 250 millibars, that's pretty high in the atmosphere. Our weather balloons regularly go to between 5 and 10 millibars, which is close to 100,000 feet and around 30 to 33,000 meters. So it's off of this chart over here, but it's very high in the atmosphere. And so it's measuring the surface temperature, the surface dew point, which is moisture, the wind speed and direction from the surface all the way up to when it pops. And so it's very helpful for us to get that snapshot of the atmosphere, what it's doing right then, and all of our observations for the weather balloons for every site across the US, which is almost 100 locations that are launching weather balloons at the same time, twice a day, every day. Those observations go into our weather models. And that's what helps us create a forecast by knowing what is happening right then and right there as a starting point. Another useful tool that our agency has been upgrading in the last couple of years is our GOES weather satellites. And so each satellite becomes more helpful, more useful with higher resolution imagery, different channels that can see various different weather phenomenon. It can be incredibly helpful to get a bird's eye view of what's happening out there. Not just with severe thunderstorms, but with wildfires and dust. It's a really helpful tool to get a view looking from above rather than just looking at the surface or looking at area webcams. So you can see the bottom left corner, it's a snapshot somewhere along the California coast. And this was a wildfire in recent years, and you can see the smoke plume from that. And that's one of our bigger weather programs here is our fire weather program. And so it's very helpful to see those hot spots that develop and how they can evolve into bigger fires. And the top middle image is a weather satellite channel. It's in the infrared spectrum, and so it just has different coloring to show dry air and moisture with clouds. That's all the yellow and the blue mean. And then taking observations at the surface gives us an idea of what's happening at the surface in one spot. And so it can't tell the whole story of everything that's happening everywhere, but when we do have weather stations, we can get an idea of what the temperature is, what the weather is like in those spots. So we rely heavily on our Department of Transportation weather sensors and weather webcams to get an idea of what the roads are doing, which helps us get an idea when we forecast for snow on the roads and how cold it will be. The image on the right with all these numbers on it, the red values are wind gust speeds. And so that's helpful for us when we're relaying to you and the general public what the winds are doing, what direction they're coming out of, how strong they are. And that helps us verify our forecast. If we're forecasting gusty winds and maybe it hasn't arrived yet, or if the winds have increased and we weren't expecting it to arrive till a little bit later. So that's helpful for us that we can fine tune our forecast and get real-time verification for us. And when we talk about weather stations that are an ASOS, that's an acronym for Automated Surface Observation Station. And so that's just an automated weather station that reports weather. So all of these observations go into our computer models. And so we use all of the real-time information, what's happening now, plug it into these supercomputers that gives us high-resolution forecast models to help us forecast out in time. And there's so many different weather models. There's hundreds of them, actually. And they all can have slightly different solutions. So this snapshot on the bottom right corner of this 9-panel snapshot here, these are 9 different versions of weather models, and they all have slightly different starting points, slightly different values in them that gives a slightly different solution. So imagine you and 3 friends are going to bake cookies, and you all say, let's bake cookies. Well, maybe you have it in your mind you're going to make chocolate chip and your friend's going to make chocolate raisin. You all are going to bake the same thing, but slightly different outcomes, if that's kind of makes sense or not. That's kind of how I think about weather models, is they're all trying to paint the same picture. Weather's going to happen, showers are going to move through, but they all have slightly different ingredients on how to get from starting to ending. And so we use those observations to help us build that picture. So this comes to your role. Why do we need weather spotters? Well, we have limitations. Our satellite and our radar and our surface observation only can help us so much. We have gaps, we have holes. Our radars can't see through the mountains, and we have gaps in how far our radars can see. At nighttime, our satellites don't see all of the channels. We can't see a visible satellite at night. Well, we can, but it's just dark. And getting a better understanding for these microclimates in the region, living up in the Okanagan Valley, those conditions are going to be very different than the Methow Valley, than the Wenatchee Valley, than the Columbia Basin. And so when we can have weather spotters in all these different areas, that helps us understand better, which in turn can help our forecast become better. So we have an interactive part of our presentation here. Let me make sure I can do this poll. Let's see, poll number 1, what is the role of a weather spotter? Okay, so you should be able to see a poll, and you should have the option to click on an answer. Okay, I see somebody has answered already. So what is the role of a weather spotter? Answer it to the best of your knowledge. It's not graded. I can't see who answers what answer. Just do your best, and we'll go over them after we finish it. Okay, good. Lots of people are answering. I don't want to click too many things, so I don't want to close this out. Wow, almost everybody's voting. That's great. Okay, I'll leave it on for another 5 seconds. Okay. See if I can close that poll. Okay. Yeah, so everybody answered the same answer. Provide reports of ground truth on severe weather. That's absolutely right. We want those reports. Let's see, how do I go back? Hang on 1 second, let me see. How do I get out of my polls? Nope. Sorry, I don't do the polls very often. Hang on 1 second. Oh, there we go. I have to share the answers. Okay. Yes, everybody answered the same thing, and that was right. So let's see. Nope, that's not what I wanted. Okay, there we go. Sorry about that. Okay, so being a spotter, what is in a spotter report? We want specifics as much as you can. We want to know who you are, so your spotter ID and location. Your name is helpful but not needed. You'll get a spotter ID and a location telling us where you're at roughly, what it is you're reporting, and when the event began or ended, if the rain started half an hour ago, if it's been snowing for 12 hours. Those are helpful things. If it's ended, if it's still ongoing, you can wait to call us, or you can call us back if you want to measure snow at the end. If you're giving us a hail size or wind speed, let us know if you're estimating or if you do actually have a measurement. For hail, it's really helpful if you can relate those measurements to coins or like a golf ball, Something that's really well known, if you give us a hail size and say it's the size of your hand, that's not always helpful because everybody has different size hands. But if you can relate it to a coin, that's universally kind of known. And also if there's damage or injury reports, if there's a broken tree branch, if there's a tree through a house, if there's a broken windshield, those types of things, those are helpful for us to know. And if you're not sure, that's okay. You can let us know that you're uncertain or that you're estimating. And if you do happen to be traveling, those are helpful as well. Just let us know. And then there's a checklist on the left, and you will get a copy of this once you get an email after this course, but you'll get a checklist on different things you can report to us. Okay, make sure slides are advancing. So various ways you can report. The easiest way is to give us a phone call. Like I mentioned, there's somebody here 24 hours a day, 7 days a week. So there's always somebody here. You'll get this phone number to call in. Again, give us your spotter ID. Let us know what you saw, what's happening, where it was happening, and the time of the event. If you want to give us a report online, our website is weather.gov/Spokane. If you scroll down past the map, there's a bunch of icons here, and there's actually one that says submit a storm report. And once you click on that, you'll get this option that looks like the left-hand side here, and you can put in a storm report. You can select the report, and it'll give you a couple different options, and it's pretty easy to use. And we are also on social media. You can always share pictures. Those are very, very helpful to share pictures. If you give us your spotter number and your location in the social media report, that's helpful. That's what we need to know. So we're on Twitter or Facebook, and our name here is at NWS Spokane for both of them. And again, we're monitoring that 24 hours a day, 7 days a week. We may not be responding as quickly as possible if we do have severe weather going on, but there's always somebody that's checking in to make sure that we're posting stuff and acknowledging those reports. And then another really cool feature is an app on your phone. It works for iPhones and Androids. It's free. It's called MPing, and you can report your weather that's going on, and it's anonymous. So we don't know your name, anything about you, but we do see the reports on a map, which is useful for us because then we get to know what's happening at a location. I just used this today when there was grapple outside. So it's very easy. I like it. I can look in on the map and zoom in and see that there's snow in Wenatchee or there's hail up in Omak. I can see what's going on the map. And so I think it's really fun to use, and it's really helpful for us as forecasters to use. And again, it's free, it's anonymous, and it's easy to use. And also you can use our email. So we have we have an email address that's monitored again 24 hours a day. That's helpful. It's an easy way to send your pictures. You can write up a little report that what you saw, and again, give us your spotter ID number and the time that was happening. So that's another really easy way to share reports. Maybe an example of not a great report would be just to call and say that there's dark clouds or that it rained a while ago. Those are kind of generic and interesting, but it's not as helpful for a spotter report. So there's an example on the left. This is Tom Smith, spotter Spokane County, number 25, calling from my home on the South Hill. So that's telling us where he's at. If he's up at the North Costco, he could also tell us that. Telling us that there's currently large hail falling and that he measured one stone, it's the size of a quarter, and when the storm began. So those are all very helpful things in a spotter report. And those are things that we need to know. On the other hand side, being a spotter means that you are giving us permission to contact you, asking what's happening or what has happened to get some ground truth. we'll do our best. We're not going to call you at 2 a.m. to wake you up. We would probably call you the day after if something notable happened. But that will help us get ground truth based on what we're seeing on radar to confirm of what's happening. A lot of times we have weather goes through an area where there's not a lot of spotters. So we try and reach out to some of our spotters to get some ground truth verification so we can understand what happened or how bad the damage was. So there's a chance we may contact you. Again, it's not going to be every day, but if there's severe weather going on, we may contact you. And so that's kind of what you're helping us with. It is very helpful to let us know to keep your email up to date and current. We do send out newsletters. We may blast an email if we're expecting widespread severe weather and thunderstorms. You may be notified the day before by an email when this is going to happen. We do send I believe it's a quarterly newsletter to let you know what's going on in our office and various training opportunities. So those emails are very important to keep up to date, as well as a phone number. Okay, next poll question. See if I can do this a little bit easier. So our question is, what is necessary to give in a spotter report? Okay, looks like it launched. Okay, so various things. We need your spotter ID? Do we need your location? What about a report that happened yesterday at 7 p.m. or all of the above? Like I mentioned, these are not graded. It's not too difficult, but kind of testing your knowledge a little bit. And again, if you guys have any questions, you can throw them in the question box. I'm going to try and monitor that as well, and we can get to those questions at the end too. Okay, I see lots of people voting. That's very good. Thank you for paying attention. Okay, 3, 2, 1, close. Okay, there we go. So most people said all of the above. That's the right answer, though all of the answers are right. There's really not a wrong answer. We do need your spotter ID. We do need your location. And if something happened yesterday at 7 p.m. that was notable, you had 3 inches of snow, you had some tree damage, you had some hailstones, but you didn't get around to calling until today, that's okay. You can do that. You can call us or send us an email of what happened yesterday. So all of the answers are correct. Okay. Okay, good. So let's talk some more about thunderstorms. So the distribution of thunderstorms across the country, you can see in the areas that are green, dark green, light green, yellow, orange. So like the middle part of the country and eastward, those are the areas that see on average 50 to 100 or more days per year that have thunderstorms. And there's even some in Colorado, Arizona, New Mexico. But the rest of the country, we're more in the lighter shades of blue and gray, where we are seeing maybe 20 to 30 days a year of thunderstorms. And then you see us up here in the inland Northwest. These are the 2 shades of gray and a little splotch of blue. That's less than 20 days a year of thunderstorm days on average. And this is from 1993 to 2018. So typically we don't see a lot of days per year of thunderstorms. Doesn't mean we don't get them, we don't see very many days. So talking about some ingredients for thunderstorms, there's several different things we need to see come together in a perfect mixology to create thunderstorms. We need moisture, we need instability where the atmosphere is unstable and capable of creating those thunderstorms. We need lift. So our mountains are a good driver of lift to help move that air upward, or a cold front also does the same thing. And then vertical wind shear. We get the winds going at different directions throughout the atmosphere, and that will help all lead to thunderstorm development. And a lot of times there's various stages of thunderstorms. You may witness them at different stages. Today I saw some of this dissipating stage where we had the rain shaft and kind of the falling apart stage outside earlier today. But when the thunderstorms start to develop, they'll get this towering cumulus stage. That's where the thunderstorm is just starting to get going, and it looks kind of like a taller, puffy, cauliflower-ish cloud. Then when they get really mature and they're just building and getting tall, these really towering cumulus clouds are just building up and up and up, and kind of this shredded, again, kind of cauliflower-looking, puffy, puffball clouds. That's the mature stage. That's when those thunderstorms are going to get stronger and produce the strong winds and the hail. And then you get this dissipating stage where maybe it's already dropped all the hail and it's rained out. It's kind of falling apart and the wind is moving it around. So that can happen in a very short period of time, very quickly, or it can be hours long. There's not really a set time that it takes. Here's another view of a thunderstorm. So you may view this at any different angle, and you may only see parts of it. But just labeling the different parts of this severe thunderstorm. On the left-hand side is the flanking line. So it's usually the leading edge of it where it's moving towards. At the ground, there'll be a wall cloud, which kind of looks like a wall. And that part could be rotating, and then it may produce a funnel cloud as it begins to drop down, and then a tornado if it touches the ground. And then behind that tornado or wall cloud, you'll have a lot of rain and hail, and that's where it just looks like the cloud is reaching and touching the ground. Up in the middle part of it, that's that mature stage of the thunderstorm with the towering cumulus, the real puffiness. And then maybe at the top, there's a part of the thunderstorm that's popped up above the majority of the thunderstorm, and that's an overshooting top. And then you have an anvil. That's where it's popped up and now it's starting to flatten out at the top. So what is a severe thunderstorm? I keep using that terminology, and there is actually definitions that we use for a thunderstorm when we describe it as severe. We are looking for winds of at least 58 miles an hour or stronger, hail that's 1 inch in diameter, so at the size of a quarter or bigger, or if there's a tornado with it. Typically for thunderstorms, less than 10% of the thunderstorms are severe. So we can get thunderstorms that have lightning and rumbles of thunder, maybe put down some brief heavy rain, but it's not considered severe. And even though lightning is extremely dangerous, it doesn't define a storm as severe if there's a lot of lightning. And I mentioned in our part of the country, we don't have a lot of thunderstorm days per year. We actually have some climatology for our severe weathers going back to the early 1950s. And you can see on this chart down towards the bottom, we get to the more present time, 2020. And you can see the number of days on the bottom x-axis goes out to 60 and 70 days per year of what we had. If it was blue, we had days of tornadoes. If it was red, we had severe hail, so 1 inch or bigger. And the green was the severe thunderstorm winds at 58 miles an hour or stronger. And you can see that typically we have more wind reports than hail or tornadoes. And our more active years were 2012, 2014, and then back in 1997. But if you keep in mind, we had our radar installed in 1998 or 1995. And so a lot more reports started coming in, and we started seeing a lot more once we got our radar. And so if we take a look and break this down by month, so you can understand what time of year we have our peak for damaging winds and hail, that would be in July. And the peak month for tornadoes is in May. And last year we did have those couple tornadoes in May, so that worked out pretty nicely. We have had severe reports in November and January though, so we can't rule it out not happening at other times of the year, but just typically when it's on average, when is that going to happen? And then time of day, we keep track of that as well. Most active storms are going to happen in the mid-afternoon to mid-evening. It's less active in the morning. You can see these values down here before 10 a.m. There's not as many values or not as many reports. And then we do still get wind reports late at night. There's been a couple of times in the past 5 to 10 years where we've had stronger winds late at night. Again, not typical, but it does happen. Okay, our next poll question. We have, what makes a thunderstorm severe? So go ahead and vote. We have winds to 50 miles an hour. Is it hail with the size of a quarter? Is it a funnel cloud? Or is it frequent lightning? What makes a thunderstorm severe? Okay, I see people voting. Very good. I'll have to ask at the end if anybody has seen large hail and what the largest hailstone is that anybody has witnessed. Okay, looks like we have almost everybody that's voted. So I will close that and we will share. So we had most people picked hail with the size of a quarter. That is correct. So in this one, there was one correct answer. Winds to 50 miles an hour and funnel cloud, those would be very close to being defined as severe, but technically that would not count. We need those winds 58 miles an hour or stronger. And funnel clouds are not technically a tornado because they're not touching the ground. It's defined as a tornado once it touches the ground. So very close. And then frequent lightning, again, it doesn't really matter how much lightning. That's not what defines the storm as severe. But all of these are great things that are very important to know for a spotter. So if you were to call and report any of these, we would take that. We would definitely need that. So don't not report it if any of these are happening. Don't just wait for it to be severe, because we can use any of these helpful reports. Okay, there we go. So a tornado, typically for our region of the country, for an inland northwest tornado, would be on the ground for about 5 minutes or less. It's going to be on the ground for maybe up to a quarter mile. Our maximum wind speeds are around 80 to 110 miles an hour. So it's usually an EF0 or EF1. So tornadoes are ranked from an EF0 being the weakest to an EF5 being the strongest. And for our part of the country, we don't typically see those really strong tornadoes. The pictures in the bottom here, the left two are from 2016. The far right is from 2016, and then the one with the red barn or the red structure, red barn, was from May 2022. So you can see a tornado. That's when that violent rotating column of air usually it has to be attached to a thunderstorm and it touches the ground, and that's when we get those tornadoes develop. So again, we don't have many days of tornadoes here in the inland northwest, but it is very notable when it does happen because they can be quite damaging. And I mentioned the tornado scale. So we have that EF scale, and it's the enhanced Fujita scale. And you can see the wind speeds there on the right, like I mentioned, typically 0 to 1 for our winds here in the inland northwest, and that's the lowest rating scale. The EF5, that's when you get the wind speeds of greater than 200 miles an hour. And if you look at the map here, the average annual number of tornadoes, Texas, Oklahoma, Kansas, even Nebraska, those are some of the states that see the highest number of tornadoes per year. And they, a lot of times, will see those EF 3, 4, and 5 tornadoes. And you can see up in our region, Washington, Oregon, Idaho, we're getting less than 5 days per year of tornadoes. And we also have statistics on tornadoes. So we've had 64 tornado reports. I believe this includes our tornado last year in 2022, that was in May. In the metro area of Spokane, we've had 15 tornado reports in our length of history from 1936 to, that should include 2022. And again, tornadoes by time of day, you're looking for that early to late afternoon and early evening time frame is when we've typically seen tornadoes. By month, May and then June coming in second, those are our highest times of year for seeing tornadoes. And then by rating, that EF0 and EF1 accounting for 50 of all of our tornadoes. We have had an EF2 and a 3, but not 4 or 5 in our history. So what about funnel clouds and dust devils? We talked about that a little bit ago, about a funnel cloud not being a severe weather report. Funnel clouds are those that stay aloft, and they're attached to a storm cloud, and they may be rotating, but they're not touching the ground. A dust devil is where it starts at the ground and it extends upwards. The bottom left-hand corner of these two images, those are examples of dust devils. Tornadoes are coming from the storm cloud all the way to the ground. So if in doubt, you can always check for cloud cover, and if there's debris or things moving around on the ground. And as always, if you're able to take a picture of it, you can always send it to us and ask us, hey, you know, I saw this. What is it? I think it's a funnel cloud. What do you think? We love getting emails and reports like that. We're happy to investigate it further, look at the radar, double check, and we'll get back to you as soon as we can. So we love seeing those things. We do have a video. So this is a video from our tornado last year out on the West Plains. I'm not sure if there's sound, but it shouldn't be a very long video here. I'll play. So it might be hard to view. Turn that down a little bit. But you can hear the thunder and see the trees moving with the wind. And then I think in a minute you'll see the trees really shake once the tornado began to touch down. So you can hear the rain starting to pick up. Yep, if you can see this light post back here, that just wiggled. I think that was part of, this was really hard to see, but so that was an example of one of our tornadoes from last year. That was tornado number 1. Oops. Okay, and then this one was another viewpoint from downtown Spokane, and this was the second tornado that touched down. So it first touched down out on the West Plains, north of Airway Heights, and then as it moved east, it then touched down out in Spokane Valley near the Avista Stadium. So we'll play this video for you. You can see right there in the middle. Yep, right where they're pointing, that tornado was starting to form and touch down. Yep, and there's a better view of it.
Boys, you're about to watch the first tornado. It's really close to forming a funnel. Oh my goodness. No, it's going that way.
So you can see that tornado was struggling to form and reach the ground, but it was doing it fairly quickly when it was forming and beginning to touch the ground. So various types of clouds are associated with lots of different storms. Some of them look worse and more severe than others. We talked about the towering cumulus, where it's really puffy and it's building upward vertically in the sky. Cumulus are those that are building up a little bit, but they have flat bottoms, so they're not, or flat, bottoms underneath it. They're not building really tall. The last couple days across the inland Northwest, we've had cumulus clouds that look like this. Scud clouds are ragged. They may be associated with rain showers that have dissipated or falling apart. It kind of looks like the cloud is shredding apart. Not necessarily indicating of severe weather, but it could be preceding or following severe weather. The bottom left corner, we have stratus. We're really familiar with that here in the inland Northwest. We get a lot of that during the winter time, and then after a rainstorm, typically hugging up those mountain areas and in the valleys. And then wall clouds, that's where that cloud is going to begin lowering. There could be some rotation with it, usually a precursor to severe weather and possibly a funnel cloud or a tornado. Not always, though. Okay, next poll question. Identify this image. Oh, sorry, I thought the image would stay on the page. I apologize if I changed it too fast. I will not do that again. So was it a funnel cloud? Is it a cumulus cloud, a wall cloud, or a scud cloud? Again, sorry, I skipped too quickly there. Forgot that it does not keep that picture. Okay. I see most people have voted. Do your best if you don't remember what it looked like. Okay. We will close that. So again, asking you to identify this image. Options were funnel cloud, cumulus cloud, wall cloud, and scud cloud. And the right answer was funnel cloud. That funnel is starting to form, but from this picture, we can't quite tell if it's hit the ground yet, so wouldn't call it a tornado, but it definitely is a funnel cloud. You can see the very narrow funnel and rope-like feature to it. Cumulus cloud, we can't really see the tops of it. Likely there is one, but can't quite see it from this picture. Wall cloud, again, there could be a wall cloud, but from this angle, we can't really tell. Scud cloud, so somebody voted scud cloud, or a couple people did. That's not wrong. That probably, there is some scud in the cloud, or in the clouds here that's being viewed. But we were more, I guess, interested in the funnel cloud part of it. So, yep. Thank you so much for voting. Let's move on to the next one. So the next element is strong or damaging winds. So severe winds, again, are defined at that 58 miles an hour threshold, and that's been defined at that level based on the amount of damage that can be done by those wind speeds. And it's been in this definition for numerous years, so I'm not sure when that exactly was decided. But the winds can be strong from a convective thunderstorms or just sustained strong winds. So a couple years ago, there's images here on the bottom where we've had times of the year with strong sustained winds, that wind speed, not just the wind gust. We've had lots of strong winds that have done a lot of damage with trees and power outages. And we've had strong downburst winds that have come right out of a thunderstorm, or straight line winds where it's just a strong gust of wind, a burst of wind moving through. And typically we see those damage reports of the trees, the power lines, and maybe even structure damage. Maybe a roof was blown off. There's a wind chart that is specifically to rate wind speed and damage. This down here at the bottom, the Beaufort number of 10, that's where we start to see that severe wind of 58 miles an hour. And that's from a storm. And there's been a lot of damage surveys that have been done to see types of damage and then relate that to wind speed. And so that's where this chart and rating came from. So along with the next element for severe weather is hail. And I had mentioned if you are able to report the size of hail and relate it to a more well-known object like a coin, a quarter, a dime, a golf ball, a baseball, a pool ball, even a softball, that's giving us a reference of size if you don't happen to have a ruler with you. Obviously, if you have a ruler, that's going to be much more accurate. But a lot of different varying styles of hail may look different. So it's good to relate it to something that's easier to measure. If you have a whole bunch of hail and there are various sizes, just pick out the largest one that you have available and report that, because likely there's a time period where some of them may be melting. Hail, depending the size of it, it can fall to the ground at 100 miles an hour, and that's why it's so damaging. That severe hail, again, is a 1 inch, and so that's the quarter size. When a storm is circulating and that water and chunks of ice is being lofted up in the storm, it's accumulating more water on it and freezing as it gets colder, and so that's what's making those hailstones bigger. And once they become so big and gravity takes over, that's when they fall to the ground. So I'd be interested to know if anybody has seen very large hail and what the largest hailstone you have ever seen is. I think in my life I've seen 2 inches, so not very big, but I haven't lived in a severe weather part of the country. Okay, so heavy rain. I mentioned flooding was some severe weather, so we are also in need of heavy rain and flooding reports. We're taking a look at heavy rain that has fallen from thunderstorms and heavy rain that has fallen just with steady rain, maybe down terrain from a burn scar after a wildfire. And so if there's been long periods of steady rain or downpours and you happen to have a measuring device, a rain gauge, that's helpful. But if there's damage reports, if there's debris on the roadway, like this upper right-hand picture, if there's flooded streets, obviously if there's flooding in a house or a building, you know, that's what we want to know. Typically with thunderstorms, convective thunderstorms, we see about a ½ an inch of rain in an hour. And if it's more stratiform, that light continuous rain, 1 inch in 12 hours or 1.5 inches in 24 hours is that stratiform persistent heavy rain. So flooding and flash flooding, when we start to see rising water on rivers, streams, low spots, or a rush of water, that's that flash flooding where it's moving very, very quickly. In the last several years, you can see on the left-hand side here in 2019, we had some heavy rain and flooding in Wenatchee. Again, after a wildfire, the Williams Flat Fire flood happened in August. And then the right-hand side, you can see we've had heavy rain in Spokane. This was May during the same event that we had those tornadoes. And then heavy rain and flooding in Pullman back in 2019 as well. More examples of these mud and debris flows. We've also seen rock slides. So when the ground becomes water saturated, that rock and mud and debris has a much easier time to flow down a slope. So if you happen to see any of these things, if you can give us specific locations, roadways, intersections, mile markers, that's going to be incredibly helpful when we go out and do those surveys after the flood and figure out exactly where it was and how bad it was. Many counties use that type of information when they have to declare emergencies, insurance claims. Those are all pieces of information that they're looking for. So the more accurate and specific we can be, that helps everybody. And so you can see the power of water. This bottom right-hand picture really stands out to me, that just the power of water moving these boulders and rocks down the hill, it can create a lot of damage really quickly. So that's pretty severe. And another weather hazard we look at and get in this region of the country is dust storms. So a large part of central Washington, north central Oregon is an agricultural area, and so there's a lot of open fields. So when we have prolonged dry periods and then we get strong winds and those agricultural areas are being plowed, much higher chances for dust storms. And so dust storms are when the visibility gets reduced very quickly. You can see this upper right-hand picture, these cars on the highway, the visibility gets reduced very rapidly, similar to like fog, but it's dust. If you can give the location of the road, the intersection, that's helpful. Mile markers, again, that's helpful. If it is happening and you happen to be in a dust storm, please be safe and drive safe and get to safety before you call us or reach out to us. We'd hate for you to be doing that while driving. Dust storms have also been called haboobs, just a different name for it, usually depending on the size of the storm. If it's widespread enough and it lingers around long enough, it can lead to air quality issues with that lofted dust in the air. And keep in mind, smoke can limit visibility as well. So there may also be lingering smoke from a wildfire nearby that can rapidly reduce visibility. Okay, lightning, severe but not part of our definition for the severe thunderstorm. Lightning can strike as far as 10 miles away from a thunderstorm. So you may be under mostly clear skies and a rumble of thunder may be off in the distance. That lightning can strike up to 10 miles away. So when our slogan is, when thunder roars, go indoors. If you see a flash, dash inside, go get to safety, seek shelter in an indoor place or in a vehicle if possible. Try to stay away from the windows and doors if you can. That's going to give yourself a better buffer of safety. And try not to use corded phones. Not sure how many people still have corded phones, but it's discouraged to do that or take a bath or a shower just because there is lightning nearby. More than 50% of lightning deaths occur after the storm has passed. So that's why we encourage people to wait 30 minutes. Those thunderstorms typically move through, but once you've not heard thunder for about 30 minutes, that's when the thunderstorm has probably exited the area. And if you're out hiking, camping, again, try and get to shelter indoor in a structure in a vehicle if you need. That's going to be much safer than being out in the open. Okay, I'm going to leave it on this page for just a little bit longer this time. So your poll question is, identify this image. So take a look at what's in this image, and then I will put up the poll answers or the selections, and you can vote. So this is number 5. Actually, and I can read off these before I throw it up. So our options for what to identify in this image is snowmelt, flooding from heavy rain, flooding from a canal break or breach, or flash flooding from a thunderstorm. And we will launch it. So go ahead and vote when you think you have an answer. Okay. Great job. I see lots of people voting. So is it snow melt, flooding from heavy rain, flooding from a canal break or breach, or flash flooding from a thunderstorm? This one might be a trickier one. Okay. Looks like most people have voted, so we will close down that. So identify this image. It looks like most people voted that it was flash flooding from a thunderstorm, with 30% of people saying it was flooding from a canal break or breach. Those two options are very close, and I would probably have a tough time picking one as well. It's hard to know if it was from a thunderstorm because I don't see any thunderstorms in the current view of this picture, but it could be a thunderstorm that went by a little bit ago because the road is kind of wet. So it could be flash flooding from a thunderstorm that's gone by, and maybe the flash flood has come down from a hillside from the left-hand side of the picture. Canal break or breach, that's hard to know because I don't know exactly where this is taken, but that's not a wrong answer. There could be a canal nearby that has flooded and overtopped. And there was a couple votes for flooding from heavy rain. That's not exactly wrong either. So there could have been heavy rain, and then we're just seeing the residual flooding. So yeah, all good choices there. Definitely not snowmelt. So good job not choosing snowmelt. Okay. There we go. So spotter safety. I mentioned again, if you happen to be driving or traveling, our first concern is your safety. So we want you to be safe first and foremost as the objective of every spotter. We want you to protect you and your family first. If you're able to give us a report later on, that's great. We want to make sure that you're safe first. So don't feel like you need to run out into the hailstorm or run out into the windstorm to take a picture of the tree when it's falling on a power line. We want you to be safe first. Don't walk or drive into obstructions if flooded roads or down power lines. That's dangerous. Don't put yourself under objects that have the potential to fall or blow over. And there's a acronym here, ACES, stands for awareness, communication, escape route, and safe zone. So if you find yourself in the need to get yourself to safety because of weather, make sure you are aware of what's happening. Pay attention to the weather. Communication, let everybody in your party know where you're going or make sure everybody is accounted for. Escape route, make sure you have a route to get out if you happen to need to be, for example, evacuating from a wildfire, or safe zone, if there happens to be a tornado nearby and we are under a tornado warning, make sure you have an area or a zone that you can be safe in. And we have another video to show, so let me show this. Okay, I thought that was going to be a wind video. That was lightning. I'll play that again real quick because it was short. If you didn't hear, there's lightning that strikes in the background. And it looks like it hit one of those trees there. So while the video is very cool, I would probably have encouraged that person to be inside. Oops. There we go. So again, lightning safety tips. The safest place is to be indoors and stay inside for up to 30 minutes until after the last rumble or clap of thunder. A safe place, you can also be in a hard-topped vehicle, obviously not a convertible, but a hard-topped vehicle, you're going to be safe in there. But it's not safe to be under a tree, on a hill, in an open field, hiking in the forest. Those are not safe places to be. And if you cannot get indoors or in a vehicle, go to the lowest area nearby and make yourself as small as possible. So you want to be as scrunched up and small as possible. Some safety tips for tornadoes. If you happen to find yourself outside, you may be able to drive away from a distant approaching tornado if you're out in a rural area and you can see it, or you've been notified that there's a tornado coming. If it's unavoidable and you're outside, you want to seek shelter in a strong building or a ditch. That's going to be your safest place. You do not want to stay in a vehicle and try and ride out the tornado. Tornadoes have the capability of lifting things up and throwing them through the air, so you do not want to find yourself in that position. If you're inside, you want to seek shelter in a strong building. An underground shelter and a safe room is obviously the best option, but if you don't have those options, being in a strong building is the next best thing. And a small interior room on the lowest floor, so that's going to be like a bathroom without windows, or even a bathroom on the lowest floor, or a closet. And if you have the opportunity to cover yourself with blankets, pillows, whatever you have around, that's going to keep you more safe. You want to stay away from windows and try and leave those mobile homes to find a better structure to be in. A lot of times we get a question about, what if you live in an apartment complex and you're on the 3rd floor? You want to try and become friends with your bottom floor neighbors, or when things are when severe weather is threatening, you want to try and go down and make friends very quickly to get down to a lowest room on the lowest floor as much as possible. Flash flood safety tips. So you do not want to cross a flooded roadway, because we saw earlier in the image that showed the water eroding away that road. We don't know what has happened underneath that water. So we don't know if the road is still intact under that water. So you want to be patient, wait for the water to recede, or find a different route. Our slogan is, when flooded, turn around, don't drown. You want to find another route. If you're in a low-lying area that is flood prone, you want to seek higher ground, go up. And it only takes 2 feet of flowing water that will carry away most vehicles, so it doesn't really take very much. Okay, another poll question. Where is a safe place to go during a thunderstorm? We've only got 2 more questions left. We are nearing the end of the seminar, or the class. I appreciate you all paying attention and staying active. It's a lot of material to go over, but we are going to be recording a couple of our classes, so in case you wanted to go back through. Okay, looks like everybody has voted. Excellent. So where's a safe place to go during a thunderstorm? We have, so that everybody answered, in a house. Yep, out of those options, the house would be the safest place to be. And again, if you're outdoors and you don't have access to a house or structure, getting in a ditch, that's not a bad option as well. Okay, so how can you stay informed? And a lot of times we use a lot of different acronyms and words that you may not understand. You can always ask us. When we talk about a watch, severe thunderstorm watch, winter storm watch, that's where conditions are favorable, but it's not imminent for severe weather or flooding to happen. We have the ingredients, but it's not quite coming together yet. When we talk about a warning, that's severe weather or flooding is imminent, is going to happen, or it's already occurring. An advisory is where something is happening, but it's maybe not as damaging. So it's a minor nuisance or inconvenient weather expected, but in most cases it's not expected to affect things really badly. So like a wind advisory versus a wind warning, that's where the wind speeds are not quite as strong, but still going to be gusty. Typically we will start days out and put a weather flood outlook, and then we move towards the potential for needing that weather or flood watch, and then we'll move towards the very short term. That's when we would do the warning or advisory. So looking in a progression of time. Short fused products, we will use a tornado, flash flood, or severe thunderstorm. Those are things that are happening in a very short period of time. Longer fused things are when we have high winds, a flood, like a river flood, a winter storm product, or a red flag product. Those are the longer fused for longer durations of time. And if you're a weather enthusiast and you want to keep track of the potential for severe weather, we have our Storm Prediction Center, and that's at this web address here, spc.noaa.gov. That's where you can learn all things about severe weather. So while our office forecasts for the typical weather every day of the year, our National Storm Prediction Center primarily focuses on the severe weather and the storms, the tornadoes, the thunderstorms, the excessive rain. That's really what they focus on. And so they will issue several different outlook products that are talking about thunderstorm risks. And so you can learn a lot on their website. And again, another way to kind of put our watch warning advisory, again, that advisory is where the hazard is occurring and imminent, very likely, but that threat is kind of just inconvenient. And we're advising you to use caution. When we talk about a watch, that's where the conditions are favorable for the hazard to occur, but maybe isn't happening yet. And it's going to be a little bit before it happens. And there is a threat to life or property, and we would encourage you to have a plan of action if things get worse. And then the warning is when things are getting worse. The hazard is occurring or imminent, and it's very likely to happen. There is a threat to life or property, and we encourage you to take protective action now. So if you are not very familiar with our website, I would encourage you to check it out. There's a lot of information on there. It can be overwhelming at times, but there's a lot of information on there. You can find our weather stories near the top. That's where we have these graphical images of weather, whatever is in our forecast in the coming days. There's lots of information in these menus above those graphics. Below the graphic, we'll have a map. And this on the right-hand side here, the map of the inland Northwest. It's all blank right now, but if we happen to have a flood watch out or a wind warning out, that map would be colored. And then down below that map, we have lots of different options for our forecast discussion, our climate graphics, our radar. There's the Submit a Storm Report button down there. And so there's lots of different things on here. You can get your forecast, submit your storm report, and check out any watches or warnings that are going on. We also have a mobile website. We don't have an app, but we have a mobile website. You can access our weather on your smartphone. So that's at mobile.weather.gov, and it's just going to be a mobile version of our website. So it's just a condensed version of our website. You can also customize it and make an icon on your home screen for your phone. And another way to stay informed, many smartphones, cell phones have this wireless emergency alert function on them. And this is where you will get an alert message for something that's happening that's imminent and big hazard to happen in our area. That's an imminent threat to life and property, like a hazmat situation, an earthquake, an Amber Alert, if it's a presidential declaration. We also have, if it's a tsunami warning, a tornado warning, extreme wind, hurricane, typhoon, flash flood, or dust storm warning. And I think there's other additional weather hazards that are going to be added to that list in coming years. But right now, that's what we have. And you would get an alert on your phone if you happen to be in the area that we've issued it for. It goes off of where your cell phone is located. There's other smartphone apps. FEMA has an app. There's a Red Cross app that has alerts and safety information about emergency info and tornado information that you can check out. And another great tool is our NOAA Weather Radio. You can order these Online, I know you used to be able to get them at some Walgreens and drugstores, but I would encourage you to use these with, or at least have batteries as a backup ready to go in case the power goes out, but it does plug into the wall. You can get a forecast. There's always continuous forecasts that are playing on there, the daily climate, and then it'll alert you if there's been a severe thunderstorm warning issued or a tornado warning issued in your area, wherever you happen to be pointed towards, whichever transmitter. So these maps down here on the bottom, the white areas are the areas that have coverage for the weather radio. So up here in the brown areas, you can see those are the gaps. So if you happen to live up here, I think the Methow Valley is in this brown area, you may not have good coverage for a NOAA weather radio, but that's why we need weather spotters, because parts of our NOAA weather radios don't reach everywhere. And stay informed. It's always good to be prepared and plan ahead, having a disaster kit and a disaster plan before the weather strikes. So that's a good thing to do on a quiet weather day. Make yourself a go bag, a go kit. These are a list of items that you can have in that will help you be prepared if the power goes out, if you have to evacuate for a wildfire or whatever it might be, just while you're planning ahead, all of the what ifs and the things you might need if disaster strikes. So ready.gov/kit has a lot of options and helpful tips for things. Other ways to get involved with weather: if you're a weather enthusiast, you're obviously taking this weather spotter class. You can join the COCORAS, so it's Community Collaborative Rain, Hail, and Snow Network. There is a Citizen Weather Observer program as well. So the COCORAS program, it's again volunteer opportunities. You help observe the precipitation. So this is just for precipitation in your community. You take the readings once a day. You can transmit it on the computer, on your mobile device, and you're helping paint the map of what happened with precipitation. You are measuring the rain or snow or both. You will get a rain gauge. You'll view the online training slideshow, set up the gauge in a good location, and it'll inform you of what that looks like. And you start observing, and you can report no value. If there's nothing that happened, that's also helpful, because that way we know where it didn't rain or where it didn't snow. So that's almost just as helpful as if it did rain or snow. The Citizen Weather Observer Program, or CWOP, that's a weather station. So if you happen to have a weather station and you want to share that data online, if you have a computer and internet access, you can register online. You'll receive a weather station ID, and that weather station will transmit every 15 minutes. And so looking at weather stations, trying to get verification and ground truth, those are very helpful. So there's more information at wxqa.com. So we talked about a lot of different programs, and it's all very useful. So no matter how you want to get involved or what you want to take part in, we appreciate it all and we use it all. So we have spotters, we have COCORAS networks, and we have the Citizen Weather Observation Program. Everything is helpful, and we use every bit of information. So we have some resources online for weather spotters. So it's weather.gov/Spokane. We have, I mentioned on our homepage, the radar and satellite images. It'll show our current watches, warnings. We'll have the maps of the weather radio frequencies. So if you get a weather radio and you want to set that up, we have information on how you can point your device. And if you take it with you camping, you can attune to a different frequency depending on where you're going, or if you happen to move. There's our access to our newsletter. Like I said, if your email is current, you'll be emailed the newsletter as well. And then we have additional training resources. So if you want to learn all you can learn about thunderstorms or lightning or everything, METED is a really good resource for learning weather. weather basics. If you're not a meteorologist, but you're super interested in weather, there's even great courses for kids of all ages to help teach them about weather. And then we do have our weather spotter training on there as well. So including this class, we have additional classes, and the advanced class, we have information about that. Okay, our last poll question. What is a good way to stay informed about severe weather? We will launch that. Okay, so this is our last question. I'm trying to end by 8 o'clock, but I still have more slides, so I'm trying to get through this. I appreciate you all sticking with this. Okay, excellent. Everybody is voting. Monitor National Weather Service webpage, have your cell phone set up to receive wireless alerts, and watch your local TV station. Okay, so about everybody voted. We have all of the above. That's excellent. There's no wrong answer. Those are all correct answers. Those are great ways to stay informed about severe weather. Okay, real quick, we threw in a seasonal outlook so you can get a quick forecast rundown. So far this year, on the left side, we have our mean average temperature from January through March. And so it's been pretty much near normal for a lot of the inland Northwest. There's been some pockets of above normal temperatures up in Okanagan and Ferry County, some below normal temperatures down in Asotin, Garfield County, parts of the Idaho Panhandle. As far as precipitation, most of the area has been below to much below normal for that precipitation. Parts of the eastern Cascades here are above normal. We had a mild and unsettled January. February, we saw some cool and dry. March was pretty cool and dry. And so far, April has been cool and wet. So our water supply, this time of year, we're really looking at our water mountain snowpack. And so on the left-hand side, these are percentage values for our water supply outlook. So lots of areas, 70 to 100% of normal for this time of year. Idaho, there's a couple of spots that are a little bit above normal. Our mountain snowpack is still near normal, near 100% of average for this time of year because we've been cool and wet. So we've retained a lot of that snow in the mountains. We're not warming up too quickly and we're not melting it off too quickly, which is absolutely where we want to be. Looking at our drought, so this goes into with our temperatures and precipitation. The outlook on the left was released just a couple days ago, and that is for us. We have abnormally dry drought and then some parts of moderate drought for northern Idaho. And the outlook for April 1st through June 30th that was released at the end of March was for drought to develop likely for good parts of the area and drought to persist. And that's typically because we're going into our drier part of the year. And so we're seeing the precipitation kind of slow down a bit. And then we're also going to be into our warmer and drier parts of the year. So wildfire becomes a big threat as well. So our significant wildfire potential outlook for June right now has us about normal for the Pacific Northwest. But then we jump into July and we start to see those potentials climb above normal. So better chances for bigger and larger and more wildland fires, which is about the time of the year when we start to see those fire potentials get higher. So we take a look. This is for April, our temperature on the left, precipitation chances on the right. We are in a below average temperature and an above average precipitation outlook, which being about mid-April now, that's kind of what we've had. We've had some wetter trends, cooler periods, and this is a general trend outlook. If we look out 3 months for April, May, June, this springtime, we have near normal chances for temperature or near near normal temperatures and a below normal seasonal precipitation outlook. And just a couple days ago, our Climate Prediction Center put out an El Nino watch. So we will be transitioning to an El Nino type pattern this summer and later into this fall. Okay, congratulations. You have made it to the last slide. We really thank you for sticking with this and tuning in and paying attention and learning as much as you can. I hope you're able to absorb as much of that as possible, but you may have questions or you may think of something later. Feel free to email us. You will receive an email after this course in the coming days with your weather spotter ID, your training certificate, and some resources as a weather spotter. And I will go ahead and unmute everybody.